Hope you're doing well today. Today is picture day, and you guys, I think the 10th grade takes pictures during your B class today. That's the second class after lunch for you, okay? So your teacher will take you down there to line up, and they have 3 different people taking pictures, and anyway, that's how that works. Okay? Tonight, also we have volleyball plays, soccer plays. How did your soccer do yesterday? Where's soccer? Any soccer players? Oh, was bad? Okay.
Let's not talk about that.
Okay. All right. And you play again today, though, don't you?
No, we don't.
Oh, okay. You play tomorrow?
Yeah.
Okay. And volleyball plays today and tomorrow, and 2 on Saturday. Is that correct? All right. And tennis. Where's my tennis players? Play tomorrow. Okay. Everybody got that? Well, let me go ahead and tell you that, if you were to start reading the chapter, they start it right away at scientific notation, but I don't. I actually pause a little bit and say, let's take a look at this chart, and let's take a look at this chart again. I've done this for many, many years. It really works. I've had people, even when they go to college and come back and say, I didn't have to look that stuff up. When they start doing that stuff, even my college textbook did scientific notation. They did powers of 10 and stuff like that. And so I think if you could see this chart for what it is, they were very smart to think, let's make a metric system based on an idea that everybody knows anyway. The same thing your number system is based on. And so that was just so smart. All right. Also, on this first page, there were 2 things that were mentioned down here that were not prefixes. Remember that? What were they? A micron, which is a micrometer, right? And the symbol for micron is just a mu by itself. But if you were to see a mu with a dash after it, it can't stand alone. That'd be micro, wouldn't it? And micro has to have something after it because it's a prefix. So you can have 3 microns. You can't have 3 micros. It wouldn't make any sense. What's the other thing on here that's not a prefix? That's down. It's on here, but it's also down here. Angstroms. Now, if the biological world, biologists use microns to measure the size of cells, and even smaller than that, maybe bacteria. Those are smaller cells than most normal cells. And then the world of atomic people, if it's physicists studying it, they would measure the size of atoms in things called angstroms. Now, an angstrom is smaller than a nanometer, isn't it? A nanometer is a billionth of a meter, but what's an angstrom? It's 10 to the minus 10 meters, which is 10 billionth, isn't that right? Okay. Let me show you something else about this chart, a little leftover stuff. This is called 1, 10, 100, and then I go back to 1 again. 1,000, then 10,000, then 100,000, and this has to be 1,000,000. It has to be. It has to be. It's a pattern, isn't it? It is. A million is 1,000,000, isn't it? Think about it. It has to be 1,000, 10,000, 100,000, 1,000,000. It is. And I can even show it to you this way. What is 1,000 thousand? What is 1,000 thousand? When you multiply numbers with exponents, you add the exponents. That's 10 to the 6th. What is 10 to the 6th? It's a million. What do you think about that? Well, nobody ever calls it 1,000 thousand, do they? But what's a billion? That's 1,000 million, isn't it? Okay. Let's turn the page. And here, this stair step, even though it's on paper, I eventually want that to be not on paper, but right up here. Get that? So let's do number 1, not the way we did it on paper, but let's do it without the paper. Milli, I'm going to go from 10 to the minus 3. So in my head, I have 10 to the minus 3 down here. Little guys, big guys, okay? And I'm going to go to kilo, 10 to the 3rd. And so how many steps is that? And instead of having your finger be on that piece of paper, you say 10 to the minus 3, 10 to the plus 3. Whoop! How many is that? 6 to the left. Now, I'm going to show you just you don't have to do this today. On the quiz, if you like, I'll have this chart for you. If you want to do your finger thing, that's fine. And I call that the underhand serve. See, it's going to go over the net. If you want to do the underhand serve, you do this. You say milli to kilo. 1, 2, 3, 4, 5, 6, 6 to the left, and then you move the decimal 6 to the left, and you'll get the ball over the net, won't you? Now, the overhand serve would be something like this. Millis 10 to the minus 3, and kilos 10 to the third, that's 6 powers of 10 to the left. And you know what? Any number. If your favorite number today is 4, if you start moving the number to the left, you start moving the decimal to the left, what happens to any number? It gets bigger or smaller? It gets smaller. When you said move the decimal 6 to the left, what you really mean is shrink the number by 6 powers of 10. Now, why would I even want you to know that? Because what if I had written this number like this? What if I had done that? If you're the underhand server, that's called concrete learning. If the underhand serve would say, well, I got to take that out of scientific notation and then move the decimal 6 to the left, and then the mean teacher is going to make me put the answer into scientific notation. You could. Or you could say, when you move the decimal 6 to the left, you're making any number smaller by 6 powers of 10. Now watch me make this number smaller by 6 powers of 10. Boom! I left off the 2. Sorry. What do you think? Whoa, that's overhand serving. Okay, let's go over here. Here's the one you didn't like. 1 billion micromoles equals how many millimoles? Here's the one you didn't like yesterday. 1 billion micromoles equals how many millimoles? Ready? Without overhand serve. Ready? Micros 10 to the minus 6. Millis 10 to the minus 3. That's 3 to the left, isn't it? What happens to any number if you move the decimal 3 to the left? Any number. What happens to it? Gets smaller. Okay, ready? What's this number? 1 billion? Don't write the billion out. Do it like you should. That's 10 to the 9th. Make it smaller by 3 powers of 10. 10 to the 6. Whoa! Whoa! Okay. That's almost jump serve, isn't it? Almost. Do you jump serve? Okay. So anyway, you don't have to. On the quiz today, you can just write the billion out and let that finger go like that. You can do it. I just want to tell you that you can go for that little bit higher level stuff. You get it? Well, you embarrassed about jump serve? You jump serve. You do jump serve, right? Okay. Right. Now, the other trick on here was, what if you just see liters or grams or meters? You know what that power 10 is 10 to the 0. Is that correct? Okay, so we're ready to move on. You did really well on scientific notation yesterday. Let's try it again. Let's just pick one. I'll just pick a number, 384.3. If I put that number into scientific notation, okay, I'm going to do like the math teacher does. Make a number between 1 and 10, not counting 10. Okay, $3.84 with a little bit extra, okay? I did that. Okay, now you're going to pay me back for my powers of 10. Okay, I'll do that. How many places did I move it? And don't say left or right, just how many places? 2. And now the original number, was that big or was it a decimal? It was big, and I know all the big numbers have what kind of exponents. So I leave it alone. Try another one. One more example. 0.000614. Put that in scientific notation. Okay, move the decimal, make a number between 1 and 10. $6.14. That's pretty easy. Pay me back powers of 10. I had to move it 1, 2, 3, 4 places. Now, what kind of number is the original number? I'm decimal. Eep. Ooh, is that something you're going to see? If you learn it the way the math teacher does it or your book, they're going to say this. If you move the decimal to the right, don't forget it's a negative exponent. You're going to mix that up. You mix it up, you're going to miss them all. I'm not going to miss them. I'm not going to do that lefty-righty. The thing we did before, that lefty-righty was my finger moved left, move the decimal left. I'm not going to forget that either. Now let's do the harder ones. What if you had a number in scientific notation, but you had to take it out? right, do that one. 4.65 times 10 to the minus 3. And take that one out of scientific notation, okay? And you shouldn't use the word left or right at all. Don't even let that come into your head. Left and right, don't do it. Don't mix it up. All right. I've got to move that decimal 3 places. Which way? Whichever way makes it a what? It's got to make it a decimal number when I get done, okay? So you try it that way. No, that's the wrong way. So 3 places. Here's 4.65. Let's move it 3 places. Here's 1. Here's 2. Here's 3. Now let's take a look. 0.00465. You're a decimal number. So am I. You think that? I know that many things in school, if you memorize something, you get it right. But if you think about this, think about it, you're going to remember it for a long, long time. You don't have to worry about, did I forget the rule? Did I switch the rule around? Okay. Now, the only other thing I want to show you, this is a little bit of leftover, is I want to show you, it does happen, this actually does happen sometimes. What if I said, put that number into scientific notation. Now, you've not seen something like this before. You say, well, wait, it is in scientific notation. No, it's not. The first part of the number has between 1 and 10, not counting 10, and that's not. So I'd like to show you 2 ways of doing this problem. By the way, you can't use your calculators until after the first test is over, by the way. This is all in your head, okay? Now, I'm going to show you 2 ways of getting this question right. All right? 2 ways. All right, so number 1. What you could do is rewrite this number as a scientific number. 4.08 times 10 to the second. See that? I could do that. And then I put this guy back here where he belongs. And the final answer, 4.08. When you multiply numbers with exponents, you do what to the exponents? Add them. So see that? See, I can't tell if this is a big or small number because this wasn't in between 1 and 10. If I have a real scientific number, I can tell you whether it's a decimal number or a big number. You get that? I can't tell in this one. Now, that's number 1. If you like this is more the underhand serve, and you know what? It's going to go over the net. You get it? If you want to do it that way, I know some people, they love this way. I don't. I like another way. I'll show you another way, and you decide which one you like. No, I like this. That's easy for me. Here's how I do it. Hey, you're not between 1 and 10. I'm going to make you between 4 and 10. Wait a minute. You just took 408 and shrunk it down. You just made me 2 powers of 10 smaller. You made me 2 powers of 10 smaller. Pay me back. Okay. Well, if I made this 2 powers of 10 smaller, I have to make this 2 powers of 10 bigger. Be careful. What's bigger than 10 to the minus 5? Oh. Okay. Either way, you get it? So let me give you another one. All right, you want to try another one? All right, try that one. I'd like you to try both ways and said, I like this way better. Try it both ways, see what happens. I just taught this to you, so I said this is a little thing here. Okay, here's method number 1. Method number 1, I'm going to take this and put it in scientific notation. That's a decimal number 1, 2, 3, 4. Okay, now put this back here. And when you multiply number with the exponents, you add the exponents. See that? That's one way of doing it. The other way of doing it is, hey, wow, thanks. You just made me 1, 2, 3, 4. You just made me 4 powers of 10 bigger than I used to be. If you made this part 4 powers of 10 bigger, you got to make this 4 powers of 10 smaller, or it won't be the same number? What's 4 powers of 10 smaller than this? Help me out. You get the same answer, don't we? I don't really care which way you do it. I don't care which way you do it. Can I ask, try to be honest, how many people prefer this method, where you actually write this out? How many people prefer that? I would, if I was taking a quiz, I might say, I feel a little more comfortable with that one. How many people like this one, the other method? Made you bigger? Okay, now everybody didn't vote. One more time. How many people prefer this one, this method? Okay, that's what I thought. How many prefer the other method? Okay, all right. You can do what you want. Choose what you want. So let's play a little game here, okay? All right, can't use a calculator. How fast can you do that problem? Can't use a calculator. What the heck are you talking about? Do you even want to do that problem? Really? I wouldn't. Let's do it another way. Let's do scientific notation. Ready? What's this first number? Next number? Next number. Are you okay? Are you with me? What's 4 times 6? Wait, everybody. 24. What's this times that? What's this times that? You have to add the exponents, right? Okay, what's 24 divided by 12? 2. So what's 24 divided by 1.2? How many times will go in there? Not 2, but... Okay. What's 24 divided by 12? 2. What's 24 divided by 1.2? 20. 20. Now, ready? What do you do when you divide numbers with exponents? When you multiply, you add them. But yeah, you're right. Subtract in what order? Top minus bottom. Everybody get that? Final answer, 20. Almost the final answer. 20 times 10 to the 8th. Am I done? No. 2.0 times 10 to the what? What's your final answer? Everybody get that? Okay, so just show you a little leftover stuff here. Let's try this one. What would that be in powers of 10? Let's see if you can think in powers of 10. What's a million trillion in powers of 10? Write it down. Write it down first of all. Commit to an answer. Commit to an answer. Everybody committed? All right. Tyler, what you got?
10 to the 18.
That's exactly right. Okay, let's try this one. Let's do that one. A billion trillions. By the way, hopefully Tyler did something like this. 10 to the 6th times 10 to the 12th, and that's how he got 10 to the 18th, all right? Let's do the next one. All right, commit. Commit to an answer. Is everybody committed? All right, Ty, what do you got? 10 to the what? Negative 18? I'm sorry. 3? Negative 3? Okay, let's try this. This is 10 to the 9th. This is 10 to the what? Trillion is 10 to the 12th. What's trillions? 10 to the negative 12. So negative 3, very good. Is that what you said, negative 3? So you know what? I got a billion trillions. Trillion's not very big, right? I'll give you a billion of them. You still don't even have one. I'll give you a billion trillions. You still haven't made up to 10 to the 0, have you? Well, those are my leftovers, and I guess that's about it. Can you think of anything that, I don't know, any questions on this one? Did you guys happen to look at some of these, or is there anything up here you say, I don't know how to do that? Let's see. I think that's about it. Anybody? All right, so the purpose of a quiz is, now pop quizzes sometimes have a different purpose, but the purpose quiz to me, I just want to know, are you with me? And I just need to know it now. I don't want you to wait till we have a 150-point test and you decide, you haven't told me, and I don't want you to not do well on that. I'd rather you maybe show me on the quiz that you weren't quite ready, and we have more stuff to do. This chapter is full. And by giving a quiz here, I'll be able to start something new, and then we'll move on. But the chapter has a lot of stuff. Remember I even took that one section out? It's got so much stuff that I had to take that out so it wouldn't get lost in all the stuff here. All right, you should feel confident. Everybody feeling confident? All right. All right, go ahead and put all your stuff up, and we're going to stop the video. They're going to take a quiz right now, and I'll send your quiz to you tomorrow.